Hey, hi Bhuvneshwari. Hi Raghu. Morning. So let us just start in next 5 minutes. I think the people are still joining in. So let us just start it in next 5 minutes. Hello, yeah, hi all. Just give me 2 minutes. We're just starting in 2 minutes. Just I'll take it. Okay. Hello, yep, everyone. So this is starting now. So I see most of the people have joined in. Oh, I think I just forgot to do that. Just give me 1 second. Let me just upload that PPT right away. I think I uploaded that last. I think I uploaded in another folder. Just doing it. Okay, so like in the last session, what we were doing was we were discussing onto the decision trees, right? So there were various things that we discussed, like what exactly a decision tree is, what are the different techniques for which we use the decision trees, right? So those were the things that we covered up in the last session. So we have some questions. Yep. So definitely, Rishabh, I'll give you a quick overview, like what exactly that decision trees we discussed all about. Okay, and for the other people also, it will be a quick brush up. So in decision trees, what we do is we follow an approach where what we do is we start breaking up the data into various leaves and nodes, right? So like small example of that is that say suppose this is a small example. Suppose you have to figure out which person will leave the company and which will not. So there will be a lot of factors on which that thing will depend, right? Like if a person has got the promotion in the last 5 years? Yes. If a person has got a promotion, what are the chances he will leave the company? If he has not got the promotion, what are the chances he will leave the company? If he has got the promotion and he has worked on less than 5 projects, so what are the chances he will leave the company, and what are the chances he will not leave the company? So what we do in the case of decision trees is that we follow an approach where, based upon the different variables, we start creating or categorizing the data, whether a person will leave or whether a person will stay. Okay, this is the approach that we follow in the decision trees. Now, decision trees is something that can be used for both classification and regression both. You can use it to predict for the kind of stuff that we have done with the logistic regression. You can use the decision trees in order to do the kind of stuff that we do that we have done with the linear regression. So it can be used for both the approaches. But the most of the time we use the decision trees for the classification problems. Okay. So what we do is basically in this, if you will see in the decision trees, it is more like, it gives us the analysis in the form of a visualization format where we see how the things are changing when we are breaking up the data depending upon the different variables. Like if I give you a small example, say suppose I want to predict uh, based upon weather, that if the weather is sunny, whether a person will come to play or not. If a weather is windy, whether a person will come to play or not. This is one example, right? Similarly, we can have, like, if a student has to go to the school and a teacher has to predict whether a student will come to the school or not. So the what that teacher, how will that teacher be able to predict that is based upon certain factors. That if like teachers see that the student never comes to the school on Friday, so she will say, okay, if it's a Friday, the student will not come. Whether if it's not a Friday, the student will come. Right. So this is how what we do is we keep on uh, breaking up the data again and again on the different factors that we have. Right. So like for this example that we were discussing, uh, let me just come to that. Say for example, this is HR of a company was trying to understand that there were 300 employees, and out of those 300 employees, 60 of the employees had left the company. So the people who got the promotion, how many of the people left from them, how many people left from the people who didn't got the promotion, right? Then based on the satisfaction level, how many people left the company who had the satisfaction level of less than 0.5 who left the company, and who had a satisfaction level of more than 0.5 who had left the company, right? So like similarly, there was another important parameter that was of projects completed. So we are saying if a person has worked on less than 5 projects, so 20, there were 140 such people who had worked on less than 5 projects. Out of them, 24 people left the company. There were 160 people who have worked on more than 5 projects, but from there also at least 36 people have left the company. So this is how what we do is we start segregating the data based upon the different variables that we have. Now the things that comes to our mind is that which variable we should be keeping at the top, which variable we should consider as of the highest significance, which we should keep at the top when we are trying to create a kind of a tree structure, right? Like you all would have seen that a kind of a hierarchy system. That in hierarchy system, what we have is at the top we have the CEO of the company. Below the CEO, there are vice presidents. Then below the vice presidents, there are some managers. Below the managers, there are some team leads. And then we have the associates, right? So we have CEO at the top because that is the highest level of designation that we have. So same is the concept that we follow in the decision trees also, that there will be one variable that we will be keeping at the top. So how do we decide that which variable will come at the top? So there are certain factors for doing that. There are certain ways of doing that. And those ways are with the help of Gini index. You can use Gini index, or you can use chi-square technique, or you can use the the entropy technique. So there are multiple techniques in order to find that out. Okay. So right, like, so how the split has to happen. So there are three techniques of doing that: Gini index, chi-square, and information gain and entropy. So in Gini index, what we do is we assume this Gini index assumes that the population from where you are trying to segregate the data, so that data is of same class. So what we generally do is we try to measure the purity of the data. So purity is, say, suppose I am saying that in a bag full of balls, all the balls are of blue color. Now that is a pure data, right? Because everything is same. But if I say there are 50% blue balls and 50% red balls, that means I'm saying this is impure data because 50% is red and 50% is blue. So 50%, there is only 50% of purity that is there in that data. So the same concept is what that Gini index follows. It sees that for each variable, how much purity do you have in that data. So what we do is we calculate the Gini index for all of the variables, and the variable that has the highest Gini index is something that is kept at the top, and the one that has the lowest Gini index is something that is kept at the bottom. So we have a formula for that, that is p square plus q square, with the help of which we can calculate the Gini index. Like for example, we did this thing, we did all these things practically also in the last session where all of you calculated these things, and then you were able to figure out which variables comes at the top and which comes at the bottom. So we were using the same example of this promotion. So where we saw that, okay, uh, if you see, we took the first variable promotion in last 5 years. So we saw that there were total 300 employees, out of them 60 had left. So what we do is, first of all, we pick up the data for yes, the people who have got the promotion. So we calculate the Gini index for that variable, which is p square plus q square. What is p square? So 8% of the people left the company. So the probability of a person after the promotion leaving the company is, that is 8%. And the probability of not leaving the company, that will be 1 minus 0.08, that means 0.92. So we calculate the Gini score for yes, then we do it in the same fashion for the people who didn't got the promotion. What are the chances they will leave the company? So we calculate the Gini index for the no, and then we calculate the weighted Gini index, right? We calculate the weighted Gini index, that there were 100 of the total employees uh, who got the promotion out of total into Gini index that was calculated, plus 200 people who didn't got the promotion. We calculate the weighted index for them, and this is how we got the Gini index score. Same way we calculate the Gini index for all the other two variables. The variable that got the highest Gini index is something that will come at the top. So we see that Gini index over here for this variable comes as 0.69, this comes as 0.68, and for the third variable we get it as 0.68. So the variable that has the highest Gini index, that will come at the top. Okay. So then similarly, we had another approach over here, that was the chi-square technique. So in chi-square technique, we follow a different methodology for calculating the purity of the data, right? So over there, the technique that we use is, that is the actual minus expected raised to the power 2 divided by the expected value, and we take a square root of that. So there's a complete mechanism for that on how we calculate the chi-square values. And then there was a mechanism that we use was entropy. And entropy, there was again a complete formula that we follow, based upon which we determine that which variable comes at the top and which comes at the bottom. Okay. So, I mean, definitely, I'm just telling you in a very quick way, because these all things we discussed in a lot of in depth, in detail in the last sessions, the last week, the sessions that we had. So, I mean, what I can recommend is you can watch the videos once and you can let me know that if there is any part of the section that was not clear to you, so we can discuss that in detail, right? So if there is anything that all of you want me to re-explain, definitely, I can do that as well. So because we have to just respect the time of everyone, so please let me know from the previous sections that we had if there is something you would like me to repeat or explain again on decision trees. No. Are you all clear on the things that we discussed in the previous session, that was more like the theoretical stuff that we did. One example, as in, sorry, Raghu, what do you, I mean,
Hello.
mm-hmm.
So can we see the calculation part instead of full parts? Can we gain index in example, and similarly for information gain and as well as this entropy and this kind. For what I'm trying to say, we need no need to calculate for promotion, project completed, and satisfaction. Any one of the things will be. So can
Sure,
you just
I'll do
take
that.
people who missed the last session classes? That's what I'm trying to say.
Sure.
Request you presentation, Amit. So till now it's not
Uh,
uploaded. This one.
I have to download it. This, I was already in the PDF format, so it has just been downloaded.
Yeah. You upload it when your time permits you.
Just give me a second. Let me just do it. Otherwise, it just skips. So in the RM articles, in the folder of the
Materials, right? Materials
R
you
material,
mean.
in the R material, I'm uploading that where we have
Okay.
the other files also.
I'll let you know once it's uploaded here.
Yeah, it's done. So it's there. You can check it out. So it's by the name of Theory Stats.
Yeah. Thanks, Amit.
Yeah. Okay. So let's take a small example, right? So how we calculate the stuff using the different techniques. So first technique was Gini index, right? So in Gini index, what we do is basically we calculate the probability of the things to be happening and the 1 minus b, that is the probability of that thing not to be happening, right? So like for the example, we had, if I take the variable of promotion in last 5 years. So let's try to understand it, because this first thing is more important, because this is something that will be used in all the three techniques also. So in there were 300 employees in the company. Out of those 300 people, 60 had left the company. 60 people left the company, right? Now what we're doing is we are breaking that up. So now up till here, no Gini index, nothing is being used, right? Up till this point, we are not using any technique. I'm just explaining you how the data looks like. So I'm saying out of the 300 people, 60 people left. And out of those 300 people, 100 of the employees, they got the promotion in the last 5 years. And 200 employees were such who didn't got any promotion in the last 5 years. Okay. Out of the 100 people who had left, who had got the promotion, see, because like now there will be all type of people who will be leaving the company. There will be people who would leave the company who would have got the promotion also, and there will be the people who will be leaving the company who didn't got any promotion. So there will be all types of people. So what we are doing is we are segregating the data on the basis of promotion. So out of the 100 people who got the promotion, we are saying 8 people left. There were 8 people who got the promotion, but still they left the company. And out of the 200 people who didn't got any promotion, 52 people were such who had left the company. Okay. Now, so first of all, we pick up the yes. So in the yes, what is the probability that a person will leave the company? That is 0.08, right? Because 8 people left out of 100. So there is a 8% chance that a person who has got the promotion, he will leave the company. And what are the chances he will not leave the company? That will be 1 minus 8, that is 92%. So this is the same thing which is being used in the Gini index. So we are saying P square plus Q square. That gives me a value of 0.8528. This is for yes, the people who got the promotion. Then the people who didn't got the promotion, what is the Gini score for them? So there were 52 people altogether who left the company who didn't got the promotion. So what are the chances a person will leave the company if he has not got the promotion? That is 26%. and the chances he will not leave the company, that will be 64%, 64, yes, 74, right? 74% chances that the person will not leave the company. So we calculated the Gini index for no. That came out to be 0.6152. Then what we are doing is we are calculating the weighted score for these two variables, which is 100 divided by 300 multiplied by Gini score of this plus 200 by 300 multiplied by Gini score of this. So what is 100 by 200? 100 by 300? 100 was because there were 100 people who got promotion out of the 300. There were 200 people who didn't got promotion out of the 300. So 200 by 300 into this. So I get a Gini index, Gini score, a weighted Gini score for promotion in last 5 years. In the same way, we will calculate this stuff for projects as well. How many people who left the company who had worked on less than 5 projects, and how many people left the company who had worked on more than 5 projects. So wherever the Gini index score will be the highest, that variable will have the highest significance. Okay. So, just to make it more clear to all of you, even before that, right, let me just come over here. So I will request all of you to please take a look at this slide for once. Okay, now this is over here. We have calculated the percentage of chances who will leave the company and who will not leave the company based upon various variables. So let me ask one of you from here. Okay. So, I mean, you can all take a look. Rather, what you can all do is just take a look at this chart. Okay, take a look at this chart, and now try to tell me from here, by looking at this, like which variable do you think is the most significance? On the basis of which variable you feel confident, that based upon this you will be able to predict it with a higher chances that whether a person will leave or not. So people, I will expect answers more from those people who are not there, because we had a detailed discussion on this in order to explain. So, okay, Rishabh, so when you are saying promotion, why promotion?
Hello, Amit. Because employees have got the promotion was something less percent of left the company, like 8%. And other, I will see the slide. There is a project completed, have 24% left. Left 17% left the company, and the satisfaction level is 17, also 17. So I think promotion is good for significant.
No, but you cannot tell just on one basis, right? So you have to compare the two things. So
Yeah,
if you just try to,
yeah, I compare both, but
see,
mainly thing for the yes.
if you see over here, basically, if you see in promotion, there are 8% chances. If a person has got a promotion, there are 8% chances he will leave the company. But there are 26% chances he will leave the company when he has not got the promotion. Okay.
Yes.
Now, if you come to the satisfaction level, there are 17% chances. If the satisfaction is less than 0.5, that he will leave the company, the chances are 17%. And there are 22% chances if the satisfaction level is more than 0.5. See, if you compare 17 and 22, they both are very near to each other, right? You cannot, if you have to predict whether a person will leave on the basis of satisfaction level, so 17% chances and 22% chances, these are two very much, both these values are nearby to each other. But if you
Yes.
see over here, 8% and 26%, right? These two values are very far off from each other, right? These two values are very far off from each other. So you can easily predict on the basis of promotion, that you can say that, if a person will get a promotion, there are very less chances that he will leave the company. But if he doesn't get a promotion, there are high chances, right? So promotion becomes significant because of that. If you see in the projects completed, there is 17% chance that he will leave the company if he has worked on less than 5 projects. And there are 23% chances that he will leave the company if he has worked on more than 5 projects. right? So these percentages are very near to each other. The difference between them is not very high. If you see, the difference is very high over here, right? So that is why we say that promotion is the most significant, because you are able to predict very highly because of that.
Yeah. So Amit, if we remove the promotion column, so we compare projects and satisfaction level. So is there a high significant level is projects completed? Because we see there is a some
Correct.
0.01. Yeah.
So there's a difference of 0.06%, and in the below one there is a difference of 0.05. So you
Right.
have higher difference over here as compared to over here. So this will
Okay.
become the second. This is the top significant. This is the second significant, and this is the third significant variable.
Yeah. So if I have a data set, so there is a many variables in there. So we can calculate one by one as a tree and calculate the Gini score, right?
Correct. So you will calculate the Gini score for each variable, and the variable that will have the highest Gini score, that you will keep at the top. Then you will
Okay.
keep the second significant variable, and then the third. This is how you define that hierarchy.
Okay. So how we calculate the which node is left on right?
Sorry.
Which node is left on right, like first is promotion is a parent node, like is significant is high, then after we will see the second is project completed, but uh, then is less than other satisfaction level, we put on right node. Am I right or not?
So you put one on the left side, one comes on the right hand side. So
Okay,
that
first.
the variable that what that comes on the left hand side, that you will generally see if there are two variables which are having the similar significant score, they will come on left and right hand side. Otherwise, you will
Okay.
only have one node that is going further broken up over there.
Okay, okay, okay. Yeah, I got your point. Okay, thank you.
Oh. Okay. Now, similarly, like one way is by the help of Gini index, you can do that. Another way of doing calculating that significant variables are, that is by the help of the chi-square technique. In the chi-square technique, what we do is basically in the chi-square, what we do is we calculate what is the actual probability, what was the expected probability. We take a square of that and divide by the expected, and then take a square root of all the values. So let's see the calculation over here. Now this is a calculation for split on promotion in last 5 years. If you take a look over here now, you will see that for the yes node, there were 8 people who had left and 92 people who stayed who got the promotion. And total there were 100 such people who had got the promotion. So out of them, 8 left and 92 people stayed. Now what is the expected probability? So chi-square assumes that 50% of the probability is that they will stay and 50% will leave. So there were total 100 people. So it is assuming that 50 people will leave and 50 people will stay. So what is the deviation that you have got? That is 8 minus 50, 92 minus 50. So minus 42 and plus 42. You get the deviation. So this is the this is the actual, and this was this is the actual, and this was the expected. Now we put all these values in this formula. Actual minus expected raised to the power 2 divide by expected, and we take a square root of that. So what you will do now is you will say 8 minus 50 raised to the power 2 and then divided by the 50, that is expected value, and you will take a square root of that entire value. So this is what you will get as a chi-square index. So you will get 4 chi-square values. You add all these values together. This is called as total chi-square. So wherever the total chi-square will be the highest, that will be the variable with the highest significance. Okay, you can just, if you all want to try it out, please do it in your Excel or with a pen and paper. You can try to do this.
Amit, can you again explain where is the value we find left or right, left or stay 5.931, 5.93?
See, for yes people, right? So there were 100 people who got the promotion.
Yeah.
Okay. So let me open up an Excel. 100 got promotion. Out of these, 8 people left.
Yes.
If 8 people leave, so these are the people who have left. So how many people will stay?
92.
92. So this you got the 92 over here. Now,
Yes.
chi-square assumes that there is a 50%. This is the total that you have. Total number of people were 100.
We will assume as a 50-50 for left and stay.
You will assume. So you will assume 50%. This is the expected as per the chi-square. So expected people who will stay, that is 50 because there were total 100 people, and
Yeah.
expected people who will leave, that
Yeah.
will be again 50. Then what you do is you calculate the actual minus the expected. So that is 8 equal to this number minus this number. Then you
Yeah.
divide this number by expected, right? You take a square of this. You will take a square of this in the raised to the power 2. Right? No, sorry, you know what, I just done a small thing wrong. Over here, you take a square of this. Raised to the power
2.
2. Okay. You get this number over here. Then what we do is you take a square root of this. Square root of this number. So you get 5.9. So this is the same number that you're getting over here also.
Okay.
So similarly, you will calculate it for stay. Then the people who didn't got the promotion, you will calculate the chi-square, the people who left and who stayed. Then you add up the number.
Hello. Amit, you are not audible.
Yeah, hi all. Can you hear me? Sorry, there was a
Yeah, yeah.
power outage that just happened.
Okay.
Okay. So this is the approach that you follow. So Raghu, others, Rishabh, are you all clear on this? How we are calculating on the basis of chi-square?
Yeah, yeah, yeah.
Amit, I have a question here. Was this covered as to why do we consider everything by 50%?
So this is the assumption that the chi-square techniques take. This is an
Any
assumption
particular
that.
reason that we do the assumption?
No, so basically what happens is like for every algorithm, right? So there are certain assumptions that they take. So this is the default assumption that this chi-square technique takes. That for everywhere you will be a 50% chances that it will be yes and 50% chances it will be a no. So for all the calculations, you will see everywhere it has taken by default as 50%. So if suppose for projects completed, there were 140 people who had worked on less than 5 projects. So we are saying expected people who will leave 70 50% of this, and expected state will be 50% of this. Okay. So basically, Raghu, in the tossing of a coin, the scenario is like that, right? Because you only have two values, right? So one yes and one no, right? So that is like it is following the principle of the probability. If suppose it's a biased coin, so in that case, if both are head, so that chances will become one, right? The probability will come as, because anytime you will toss it, you will always get head only. But in this case, what it is assuming is that even if the coin is biased, then also it will assume that 50% chances are heads and 50% chances are tail. So that is what that assumption of that chi-square is. Then the next technique that we follow in order to calculate the significance of the variable is the entropy. Now, entropy is basically a technique to measure the randomness or uncertainty in that data. So when we talk of uncertainty means basically where we are trying to understand that how much the data is varying, right? It calculates again, the concept remains the same, that is purity. So we are talking on the terms of how pure the data is or how impure the data is. So now, for example, if I say that, okay, say suppose, this was a small example that we discussed like previously. Say suppose I have some variable. This is a variable. I'm just calling it as var. Okay. So there are 10 ones in this. Now this data is completely pure. Okay. There is no, every point is the same. So this is called as the pure data. There is no heterogeneity, right? Heterogeneity means there is heterogeneous. Hetero means more than one value. There is no more than one value. So in this case, your entropy will come as 0. Your entropy will be 0 because everything is same. All the data is same. Okay, so if I'll calculate the P, so if I calculate the probability of having a 1, that will remain as, 1 only, because all the values are 1 in this case. So the entropy will be 0, and you have a formula for that also to calculate, and the formula is minus P into log 2 of P minus Q into log 2 of Q. Okay, P and Q are the probability of success and failure in that node. Okay, so if all the data is same, the entropy will come as 0. But if suppose I change some of the values, I make this as 2. Now most of the data is same, but there is one value that is different. So what will happen in that case is entropy, you will get some entropy, the value of entropy will increase because there is some heterogeneity that has happened. If suppose this is also different, entropy will increase further. This is also different, it will increase further. This is different, this is different, this is different, this is different, this is different. So all the numbers are different. In that case, entropy will come as 1. 1 means all the data points that you have are different. You have 100% heterogeneous data. Okay. And when all the values were same, I was saying there is 0% heterogeneous data. All the data is homogeneous. You only have one kind of data point with you. Okay. So this is called as entropy. Now, when you calculate the entropy, so for a variable to be significant, the entropy should be the lowest, right? Like for example, if I say that 1 and 1, 0 and 0, you have to predict whether it will be a yes or no. So I'm saying yes, yes, and no, no. Now in this case, my output is clear that, if it is 1, it will be a yes. If it is 0, it will be a no. But if my data looks like this, 1, 0, 1, 0. Now in this case, what will happen is that at 1 and 0, you have both yes. So you cannot predict. So based upon the value, you will not be able to tell, okay, if it is 1, whether it's a yes or a no. You will be confused. Same will be the case over here as well. And same way, if the data looks like this, 1, 0, 0, and 1, again, you will be in a dilemma that what will be the outcome? Like, because it can, on 1 also you have yes, on 0 also you have yes. So how will you tell whether something is yes or a no? Okay, so this is where this entropy comes into the picture. So entropy helps you identify that if you see over here, for yes, everything is 1, for no, everything is 0. So this is like a pure variable that you have, because on the basis of this variable, it is easy for you to predict whether a person will buy or not. But basis this variable, it will be difficult for you to predict whether a person will buy or not. So with entropy, there is one more thing that is related, that is called as information gain. Okay, so now across which variable do you think that you are able to predict in a better way? If this is variable x, this is y, and this is z, according to you, which is the variable on the basis of which you can tell that, okay, this is the variable, if you give me this, I will be able to predict whether a person will buy or not? X, right? And what was the entropy in case of x? What will be the entropy in case of x? Entropy will be 0, right? Because if I pick up the data for yes, everything is 1, so data is completely homogeneous. Okay, entropy will be 0. So information gain, the formula of information gain is 1 minus entropy. Okay, so what will be the information in gain? What will be the information gain in case of variable x? That will be 1 minus 0. That comes out to be as 1. That means there is a 100% information gain. You are 100% sure you will be able to predict whether he will buy or not. Okay, that is called as information gain, and which is calculated just as a calculation of entropy, which is 1 minus entropy over here. So this is how you use this entropy and information gain in order to understand which variable will have the high priority and which variable will have low priority. Okay, so let us see the example of that over here.
Amit, if in a x variable there is a 3 ones and 2 zeros, so what's the entropy of that column?
The entropy is calculated on the basis of predictor variable. That
Okay.
if you have to predict yes, for yes, how much pure data you have, for no, how much pure data you have. So based on that, you calculate that entropy. So if you will see this calculation over here, it will make the sense to all of you now. So if you see over here, I'm calculating the entropy. So I'm calculating the entropy for yes node. So there were 8 people who left the company, right? So probability of leaving the company, if a person gets a promotion, that is 8%, and the probability he will not leave the company, that is 92%. Okay, so if you see now that the people, if I just put that thing into this formula over here, minus p into log 2 of p minus q into log 2 of q, you will get the entropy rate. So the data is 40%, I can say. So it basically tests the impurity. So 40% is impure, right? Basically it is telling you that for yes, so 40% of the chances, there are 40% of the cases where you might not be able to predict, but the rest of the 60% of the data, you are much more sure that what will be the outcome in that case. Okay, so you calculate that entropy for yes, then you calculate it for no, and then you calculate the weighted entropy, right? You will calculate the weighted entropy over here. So that is the same technique, 100 by 300 into the entropy this, and 200 by 300 into entropy, that is this. So you will get these values over here. Now what will happen, what you will do is, now entropy is something that works in the opposite direction, right? So for a variable to be significant, the entropy should be high or low? Yes, please tell me. So for example, in this case, like we were seeing this example over here, we saw that for this the entropy is coming as 0, and because of this we are able to predict our output, right? So entropy is the lowest, that is coming as 0. You cannot have an entropy lower than this. So entropy is something that should be low. Lower the entropy, better the variable, right? And if the entropy is low, your information gain will be high, right? Because information gain is 1 minus entropy. So 1 minus 0 gives you 1, right? So what we do is, either you can calculate your significance on the basis of entropy, or you can calculate on the basis of information gain. So you are saying either if the entropy is low or the information gain is high, the variable is more significant. If the other way around is happening, you are saying the entropy is high and the information gain is low, then the variable is less significant. Okay, so this is how you calculate the significance of the variable on the basis of entropy. Okay, so this is the technique, or these are the methods that we follow when we have to calculate the so yeah, Prabhu, so you try to now, if I just give you this thing over here, now you try to calculate this over here. So on the basis of this data set that we have, I mean, Raghav, so you can just try to follow this. You will say yes and no, right? So if you pick up the things that are yes, so there were total 2 outcomes for yes over here. Okay, in case of one, it was one is yes and one is no. So how much entropy should I get? You should be getting in this case. You will pick up for yes. How many data points do I have? For yes, I have 2 data points. And what are the chances that it will be yes? And what are the chances for no? So there is one case where I am saying it will be yes out of the 2 outcomes, and for no also I have one outcome. Now try to calculate the entropy for this. So use the same formula, minus P into log 2 of P, right? So 1 by 2, this will be P will be 0.5, right? And over here also P will be 0.5. So if you try to put that thing into the formula, that is minus 0.5 multiplied by equals to minus 0.5 into log, number is 0.5, base is 2. Okay, you get 0.5 over here. Similarly, if you see over here, now in this case you come up, the another variable that was q, right? Q will be again the same value you will get, minus 0.5. So that will be again 0.5. You will get the entropy as 1. Are you all with me? Yes, class? So how much entropy do I have got? I have got the entropy of 1. 1 means every data point is different. Okay, so in case of yes, I just had 2 data points and all the 2 data points were different. One was, in case of y, it was 1 and it was 0. So I got the entropy of 1 over here. And what is my information gain? Information gain is 0. I cannot tell on the basis of y whether a person will buy or not, right? There is no such. On 1 also it is yes, and 0 also it is yes. So my gain is 0. So that way this variable is insignificant. Just let me give you one more example. I mean, same example only. Let all of you all now try to calculate. This is the variable. Now try to calculate the entropy for this. Yes, Sakshi. So information gain and entropy, both of them will lie between 0 to 1 only. Now try to calculate the entropy for this. Let's see who can do this. So you have to give me the entropy for yes, entropy for no, and then total entropy. Right, the formula for entropy is minus P into log 2 of P minus Q into log 2 of Q. Anyone who has calculated this? So if we see how many total yes we have, so if we see total we have as if you just calculate the yes, we have total 7, right? We have 7 yes over here, right? Now, in case of 1 and 0, okay. So what is the P that you will get? What is the value of P that you will be getting over here? So in the case of yes, so 1, 2, 3 and 4 and 5. 1, 2, 3, 4, 5, right? 5 are 1 and 2 are 0. So P will be, in this case, it will come as 5 by 7. Okay. So now if I calculate the entropy for this, what will be the formula? I will be saying equal to minus P multiplied by log, my number is this and base is 2, right? This is what I will write. Am I right in this? P into log 2 of P, we get 0.34673. With this, we also have to keep minus. So let me just calculate the Q also. This was P, and let us calculate the Q as well. Q will be equal to 1 minus this number. Okay. So I will say minus this multiplied by log of this number base right? So we are getting an entropy of 0.86. Okay, what will be my information gain? Information gain will be, this is my entropy, and what will be my information gain? That will be equal to 1 minus this. This is the information gain that I'm getting over here. Okay, are you all able to calculate this value? So Sakshi, it should not be minus. I think you would have got something wrong over there. Okay, now similarly, you will calculate the same thing for no as well, right? In the case of no, how many 1 and how many 0 do I have? So in case of no, we have total 3 of the cases. Total 3 cases are there. Out of that, 1 we have over here, which will come as equal to 1 by 3. Okay, so I've not calculated for 0 over here, right? I mean, you can all calculate for the 0 also, and you can then calculate the weighted. So this is the P that I have got. And similarly, you can calculate the Q, which is equal to 1 minus this. And then what I have to do is I can simply copy this formula over here to get this. So the same formula. So Excel has this advantage, right? It shifts the cell, it moves the cell according to that. And we can see entropy and information gain being calculated. Okay. See, these calculations, they look little, tricky, but if you just break the formula one by one and then you calculate it, it will become easy. If you will try to put all the things together in one go, you will get confused. So the best way to understand it, first of all, do it step by step. Calculate the P, calculate the Q, then put it into the formula minus P into log 2 of P minus Q into log 2 of Q, right? So that way you will be able to put that thing very easily into that formula. Okay. Please try it out and let me know if you. Are you able to calculate this? Shall I move ahead? Okay. So now, we will try to understand these things practically with the project that we have, right? So I will request all of you to please download that project of the decision trees from your LMS. So I hope you all would have downloaded it, right? In the previous class we were discussing. So the people who have not, please download the same. The decision trees, the project on decision trees, which is there on the LMS. I hope you are able to download it. Not the insurance marketing, it would be on the churn analysis in telecom industry. Let me show you. Right, got it?
Amit, this is Bhavani here. The one you're sharing is a shade drive, is it? No.
No, this is the Ematicus LMS. You need to log in with your ID and password on your LMS, and over there you will be able to find it.
Where are the recordings saved?
Recordings are on the YouTube, so you would be getting a separate link for that.
No, the session recording.
That only I'm telling you. For that you get a link of YouTube, right? From where you can see all those videos.
Can you share that, please?
As to that, not access.
Okay.
So in a group chat, you can just put it. I think if anyone of you is having that video link, please share it with Bhavani over here so she can access the videos. So over here, you will find this decision trees using R, and you have a class project. So from here you can do it. Okay, you can download this project from here. So I can share this link also if any one of you is having any troubles. You will just have to click on this and you will be able to access this. Oops, so it's already shared. Thanks, Michelle. See, this problem statement is regarding one of the very common problems that we find in telecom industry, right? So this is regarding the churn rate, whether a person will stay or they will stop using their services. Now, this churn analysis is something that is used a lot, not by just the telecom companies. They are being these days used a lot by these OTT platform as well, right? The Netflix, the Amazon Prime. They also do a rigorous analysis to understand how many customers will stay with them and how many people will leave their services. Okay, now that is what the objective of this case study is. So if you will read the problem statement, you will get a complete understanding that customer churn occurs when customers or subscribers they stop doing business with a company, also known as customer attrition. It is referred to as loss of clients or customers. One industry in which churn rates are particularly useful is the telecom industry, right? So in the telecom industry, the this churn analysis is used a lot, right? And then what you all have to do is you have to build a classification model using the decision tree algorithm to predict whether the customer will stay or will he leave. Okay, this is what is expected to be done. So all of you please take a look at the data set as well. So we have this data set also. The data set is this, the churn data. You will see you have the customer ID, the gender of the customer, senior citizen, and whether he has a partner or not. So you have all this data present with you, and you have a data description as well. Please just spend 2 minutes to grab this data, all about what this data is all about. Okay, so shall we start on this? Right. So now what we will be doing over here is there will be certain libraries that we will be using. So I will keep on telling you what exactly for what purpose we will be using the different libraries that we have over here. Okay, so for now, we have the plier library. The plier is something that we use for data manipulation only. This is something that we use for data manipulation. So first, in the starting itself, we have specified at which all libraries we will be using. Why do we use corplot? Can anyone tell me what is the purpose of using the corplot library? So we have used this library in the past as well. Right, so correlation plot, perfect, right? So we use this for seeing the correlation chart. So we use this for that purpose. ggplot, we
Amit,
all
can
know for
you
creating.
put the all the libraries in chat box?
Just do that. Okay, we use ggplot for creating graphs, right? We used ggbar, ggpoint, all those charts. Grid extra is just used to see if you want to see charts in one single view. We use for that purpose. Viewing multiple charts in one window. G themes we know. Why do we use caret? Right. So this is something exactly right. So this is something very similar to the CA tools, right? We use this for the Sorry, I just changed my network again. Actually today I don't know why there is a lot of the power outage is happening. It is power is going on off again and again. So the modem goes off, so I just connect to the mobile hotspot. So I'm really sorry. Are you all able to hear me now? Okay. Now, similarly, we have a couple of the libraries that we will be using over here. Okay. So let me first of all do one thing. It will be better, let me just first of all share all these with you. So you all will also have to run the commands like install.packages, because I am just sharing the library command over here. So first of all, you all will have to install them for the first time. Only then you will be able to put them into the library. So please do the needful. First of all, just install all these packages. It should not take more than 2 minutes, 2 to 3 minutes. You can just write your command, install.packages, and keep on installing these libraries.
Hey, Amit, I have one doubt. Okay.
Yes, Ravi.
Okay. For example, I just checked my vice president data science. Okay. So he usually will ask whether you use the coding or you using the packages. Okay.
Sorry.
So I discussed with my vice president, data science vice president in my office. Okay. So he usually ask, okay, whether you using packages or coding.
We're
So
using
is there,
packages.
we are using packages, right? Yeah. For everything like carrot and this one. Libraries we are using, right?
See, it's basically what we do is we use coding plus packages. Okay. So what happened
Okay.
is basically in the R for doing certain kind of tasks, we have different packages that are available. So like if you have to
Correct.
do the manipulation, you use the player package. So first we install the package so that we can get an access to all those functions, right? So then we write our codes in order to use them.
Yeah, that I understood, Amit. What I'm trying to say, ask you. So instead of using library, can we do the coding also to do this activity? For example, read, okay, Excel. Okay, we are using read Excel, right? Instead of using
Right.
that, possible to write a coding to fetch the data. So is possible, right? Instead of using the library also. Hello.
No, so without library, you will not be able to do it because you will not get that function of using that Excel. So
Okay.
yeah, can you hear me, Raghu?
It's breaking. Yeah, it's now comparatively better. Yeah.
Okay. I think the question that you're trying to ask is that you want to import the data, but is there a way that without using a package, if we can do that same thing by writing the code by
For
ourselves,
example,
right?
using a mean like a functions, like you use right some function, mean function. Similarly, if I consider if we don't have a net, okay, okay. So if we because if we need to install the packages, but what if we have an internet only, right? But if we can use the functions, we can use directly without a net. So if we don't have an because I don't. He asked that question. He asked that question whether you people use packages or you use the directive for everything is coding.
No, so we use
So
packages. We use packages.
they will vary whether is it good if you are not using much more packages, is it so, or we can use as much as packages.
No, you can use as many packages as you want. So
Okay,
if you
okay.
will try to write the code, so that will become very, very lengthy, right? You will have to create your own functions and it will need an extensive amount of coding. The work that you will be able to do in 1 hour, you will spend up
Mhm.
Hello? Yeah, hi all, can you hear me? Okay, okay. So yeah, sure. So let's just get started with this. Okay. So over here. So first of all, my first step over here will be to get the data into this R environment, right? So what will be my first step? So wherever my file is placed, I need to make that particular folder as my working directory, right? I need to make that the folder as my working directory. So what I will do now is, so what I will be doing over here now is I will first of all go to that folder, what that folder is. So okay, let's open it up. And we have the data set over here. I'll set this as my working directory. Okay. Now what I will do is, first of all, at my first step, I will load the data from this churn.csv using the command read.csv. I'm sure all of you would be aware with this. The first step that we are going to do over here, right? Read.csv. So this will get the data for us. So we have 12,335 rows of data and 21 variables. So why do we use head command? So head command is something that we use to see the top 6 rows. Perfect, right? So I will say view head of this. So it will show me the top 6 rows of my data. So we have the customer ID, we have the gender, we have partner. So what was partner? So whether partner is, if you will go and check your data dictionary, you will be able to understand like whether his partner is also using the services or not, how many dependents and how many dependents he has, whether he has any dependent in the family or not. Tenure is basically for how long he has been using the services of the service provider, right? Whether, and then you have certain variables like is he using a call service, yes or no? Is he using multiple connections, no? Phone service, yes. If he's using multiple connection, so you have again output in the form of yes and no. Is he using any internet connection, no? Or if he is, what type of internet connection is he using? Is he using any online security, right? So online security is something that definitely if he will be using the internet, then only he will be able to avail the online security, right? If the person is not having internet, so definitely he will not have internet service also, right? He will not have any online security also, he will not have any online backup also. So these becomes by default as no over here, because he is not having internet connection only, he is not using the internet connection from the service provider, right? Like it happens, right? Like for example, from the Airtel, many of us people, what we do is we take the phone line and we say we do not want the internet. Okay, so if I'm not using their internet, they will not be able to provide me any online security also, correct? So that is why it becomes automatically no over here. But yes, if I am using the internet, so I call up Airtel and I say that please provide me your internet connection also. Now after that, it depends upon me that whether I will like to take the online security or I will not like to take that security. Now that becomes an option for me. So that is how this data is given to us. So then online backup, right? So you have the device protection service, the technical help, online TV, online movies, agreement, how, what is the tenure of their agreement, and what is the billing method that they are using, right? So billing method is, if you will see, let me just open that dictionary also, data dictionary as well. Okay, so you will see over here, this is the agreement. A customer might have a month-to-month agreement or a one-year connection. Billing method means whether a person has subscribed for paperless billing or not. So all the different variables are given to us based upon, based upon the data that the company has collected about their each customer. Okay. Then what are the charges of his monthly, what are the monthly service charges? What is the total amount he pays on a monthly basis? Then no and yes, whether a person left the company or he didn't left the company. So you have all that data of churn. So no means he didn't left the company. Yes means yes, he left the company. So churn means yes, left and started using some another services. Okay, are we all clear on the data now? Anyone having any confusion on the data that we have? Perfect. Now we will try to see the structure of this. We would like to see the structure of this data frame, right? So str is used for that. So we can see what is the data type of each of the column. So we have character and numeric variables. Okay, so we have 12,000 rows of data and 21 variables that we have inside this. Okay. Now, then what we will now start doing over here is we will do the EDA process. We will start our EDA process over here. So before that, even before we go to that process of EDA, can you all quickly tell me that how many rows do we have for no and how many rows do we have for yes? Can you all quickly check and let me know about that? And please share the code also that how you have done that. So for how many customers the data is no and for how many customers the data is yes? Yep, anyone? Table command, right? Remember we used one of the command was table. Can we use the table command in order to figure out how many no and how many yes do we have? Right, so please try that out. See, EDA process is something that will remain consistent every time, right? Those functions that we have covered, they are something like the base, right? Any type of analysis you will do, everywhere you will find that. Right, Hermes. So that is table df churn $churn variable. So it will tell you how many yes and how many no do we have inside that. Okay. So what we will be doing over here is we will simply write the command table and we will say the name of the variable is the data set is df. What was the name that we gave? df underscore churn $churn. So it tells me there are 6,728 records where the people have not left the company and 5,607 records where the people have left the company. Okay. Now, what we would like to do now is we would like to check for the function that where all do we have the do we have any missing data in our data set. So I hope we did this as apply functions in the last session, right? We try to cover like the different type of apply functions that we have, right? So we are using the apply function and this is the data set and the function that we are applying is we are checking is.na. Anyone who is not clear on this function? Please let me know. So this is a quick function that you can use, right? So what we are doing is for each variable, right? Each variable we will check if there is any missing value inside that. If the missing value is there, the output will be 1, otherwise 0. So we add up all the ones. If the sum comes out to be 0, that means there is no missing value. If the sum comes out any number more than 0, that means there are those many missing values in that variable. Correct? So if you will run this, everywhere I'm getting the sum as 0 over here. Right? So everywhere we are getting the sum as 0, that means there is no missing value in our data. Please, all of you, please try this out. Okay, and then you can also use one of the other functions, that is count, right? So count is basically a function that you will get as a part of a flyer package. If you type count, okay, you need to have flyer package installed with you. So now I'm just telling you some more stuff, right? You could have, we can easily see that, you know, how many gender do we have. But if you install one of the packages, that is plier, the plier package is also something that is used for data manipulation. So this will give you one function, that is count. So what is the name of your data set? That is df_John. Okay. Then you give the name of your variable. So suppose you want to count gender. So let me just check gender. How is it written? All in small. So if I write gender over here, it will give me the frequency count only. So this is as good as the table function. So you could have used table function or you could have used count function, but this count function will be available as a part of plier package. So it tells you these many are male and these many are female. Okay. Similarly, you want to count this stuff for any variable. So if you will see senior citizen. Now in the senior citizen, you know, you will find that there is some discrepancy in the data that you have. Okay, if you will try to take a look at the data set of, if you will try to take a look at the data set, okay, let me show you. Let me open up that Excel. Okay, if you will see, you know, in this senior citizen, you will find there are a lot of values that are coming. Okay, technically the data dictionary tells you that the data dictionary is telling you that you only have 2 type of values. So if I come over here, senior citizen, yep. So this column describes whether customer is a senior citizen, yes or no, right? 1 means yes and 0 means no. Now, if this is the case, like 1 is yes and 0 is no, but over here you are finding some data discrepancy, the numbers are coming in the decimals also. So how can I rectify this thing? What approach can I use to rectify this data over here? Anything that you can suggest? So you are saying round it up. Okay. So how the rounding will work? I mean, you are right in your approach. So rounding, what that will do is if the number is 0.6, it will become 1. If it is 0.4, it will become 0, right? That is how the rounding works. If the number after the decimal is, so can I use that if condition that if the number is less than equal to 0.5, we can call it as 0, otherwise 1. Can I use that? So right, Sakshi, so that is the approach that we can follow. So we can use the if else formula in order to rectify that data. So we will do that now. Okay, so similarly, you can use the count function for all the variables. So which is not a necessary, but I've just given these as a pointer that if you would like to try it out. Okay, you can try it out on all the variables at how the data is given to you. Okay. Now, so first of all, let me just do that step over here. That is senior citizen. So what you all need to do now is, first of all, you need to correct those values. You will use if else formula to say that if the values are less than equal to 0.5, you want to call it as 0, otherwise 1. Please do this. And what we have is, so I'll also keep pinging these things on the chat also in case if anyone gets stuck somewhere. So you can follow from here. Now what we will do is we will do some data cleansing. So data cleansing is right, like now this is a optional step, right? Even if you do it or you don't do it, the things will work fine. Okay, we have the data in the form of codes. 0 means he's not a senior citizen. 1 means he is a senior citizen, right? So what we're doing over here is we are encoding it. We are trying to bring the data in the form of yes and no. So this is like an optional step. This is something that we're just doing for the purpose of exploring more functions in the R. Okay. So if you have to do this thing, so there are two ways of doing it, right? One is you can first convert the data into the factor, and then you can say if the value is 0, make it no. If the value is 1, make it yes. Can you all do that by that way? I hope you can all follow that approach. How can I convert a variable into factor? I will say the variable that we have, $citizen, I would like to convert it into as dot factor and the name of the variable, that is df underscore churn $senior citizen, right? This command will convert the variable into a factor. Correct class? And if I want to convert the 0 into no and 1 into yes, I can straight away write my condition over here. This is a similar condition I will write. I will say that if else, if the value is equal to 0, I would like to call it as yes, otherwise no. Now this is a technique that I can write, and I hope all of you would be now well versed with this. But of doing the same stuff, we have one more way of doing that, and that is with the help of map values function. Okay, now map values function is something, if you will just write map values, this is again a function that you will get as a part of plier package. Okay, now this is also something that is used to use in the kind of a if condition only, or maybe I can say replace the values. So how we use this map value function is, let me show you. So what we are doing is we are saying I would like to update my column of senior citizen. I am saying first convert all the data into as.factors and map the values, right? Map the values. In the map values, what we do is we write like this. We say map values, okay? Then what you do is you define your dataset name, that is df underscore churn. Then you define what are the values you want to update. I want to update the 0 and 1 to, you specify 2. What values do you want to update them into? Into no and yes, right? So what this will do is, so we just have to write C also. Okay, so this is how you write that function map values. Now what map values will do is it will pick up the column $senior citizen. So it will pick up the values. Wherever it will be 0, it will be replaced with this. Wherever it will be 1, it will be replaced with this. Okay, this is how the replacement of the data will happen. So you can follow any approach. If you would like to go with this, you can try this out, right? This is a new way of doing the same thing, of replacing the values. You are saying update the values from 0 to no, 1 to yes. And it is like in the form of that plain, the way we interact. Coming in the form of yes and no. Okay. Hey Raghu, can you hear me? Class, are you having some trouble with my voice? Okay. Right, are we clear on this point? On how we have replaced the values from 0 to 1? So two ways, and I have just shown you both the ways over here. Okay. Now, what I would like to do over here is that, in this data set, there are a lot of variables where we have written no internet service, right? So when a person has not enrolled for the internet, so for all the other options, everywhere where the person is not having an internet, we have written no internet service, no internet service. So, because of this, what is now happening is there is a kind of a new category that is being created, right? So one is no internet service and one is no. And both of the things mean no only, right? If I say online security, he also doesn't have it and he also doesn't have it. So instead of creating multiple categories, can I not convert this value to no itself? Because this also means a no, that the person doesn't have the service, right? So how can I do it? So if I have 1, 2, 3, so rather than writing that function for each variable separately, can I do that thing with the help of a loop? Right? I can achieve the same thing with the help of a loop. So I can say that for all the variables starting from here up till I guess it is going up till here, online movies, right? So no, Risha, we do not need to check the internet service, right? We can simply, because everywhere the data is consistent, I have to replace the no internet service with no, right? This is what I have to achieve, right? So what I can do is I can run a loop that it should pick up the variables starting from here up till here, it should pick each variable one by one. And in each variable, if no internet is coming, no internet service is coming, it should be replaced with no. Okay. So we will write a loop for that. We will write a loop condition for that. So we are writing that we have created a variable by the name of column names. So from 10th to 15th, these are the variables in which the value has to be replaced, right? So 10th, 11, 12, 13, 14, 15. So there are 6 variables. So if you will take a look at this, so it is starting from which variable? So if you start counting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. From the 10th variable, no internet service is starting. So 10th, 11th, 12th, 13th, 14th, 15th. From 10th to 15th, we have to apply the same logic. So instead of writing the same stuff again and again, what we are doing is we are writing a loop. So we are saying for I in 1 to number of columns, that is these many number of columns, what is the formula that we are applying? The same formula that we had applied on that the senior citizen variable, right? We are saying as dot factor map values, wherever the value is no internet service, it should be changed to no. That is the mapping that we are doing. So I will suggest, you should try to write this by yourself, because this is something that you all should be able to write. Anyone who is not able to understand this formula, this code, sorry, not the formula, the code. Are you all able to grab it? Yep. Yes, Raghu, you can do it. Replace. You can use the replace function. You can. So as I said, right, there are multiple ways. You can use the if condition also. If else, if the value is equal to no internet connection, replace it with the no, otherwise whatever it is. So there are multiple ways of doing the same thing, right? And it should be a good approach, right? If you want to learn it in a better way, you should try to achieve the same result by writing that same stuff 2 or 3 ways. So that will give you more confidence also and more understanding also. Okay, so like one way you will learn in the class and try to implement the another way in your own practice. And if you get stuck somewhere, come back to the session and ask your doubt. Okay. So I'm just sharing this part of the code with all of you in case you would like to write it, or if you are writing it by yourself, that is the best thing. So let us execute this. So now if I will check my data set, wherever it is no internet, it has been replaced with no now. So now you will not find any no internet connection. Everywhere it is no being written over here. Okay. Sure, I'll do that. So this was basically this was the code that we executed, and there was at the top there was another way of that. So I'm sharing both the ways. This is the first. These are the 2 ways that we discussed. Okay. Now, similarly, we will make a change in one of our variable, that is multiple connections, right? So you have a variable of multiple connections where it is written no phone service, right? So no phone service means no multiple connections. So instead of having this also as a separate category, we will replace this also with no over here. So we are right now bringing the data on in a structured format. So everywhere I've used the same formula, that is map values, which will help you achieve that. Oops, something went wrong. Okay, so I've just replaced the no phone service to no over here. This we have already done. Okay, so the data changes that we required, they are already done now. Now we will be starting with the process of removing the columns which we do not need for the analysis. So we will get rid of those columns which we do not need for analysis purpose. Like one such column is customer ID, right? We will not be using customer ID anywhere in our predictive model. Like we will never say the customer ID is this, he will not leave. If the customer ID is this, he will leave, right? So we can remove that. So we will remove customer ID from here. Okay. So this is where, I think I'll take a pause for today, right? So I will expect all of you to please, be prepared up till this step, and you can collect your questions or queries in case if you will have any. And from here, we will be taking up the things ahead. Okay.
Yeah, Amit, can we have session tomorrow 8 to 10 instead of 10 to 12?
Actually, this is like a weekend. So actually, I have some guests at my place. So due to which, I let it this way.
Okay. Fine. Okay.
Okay. Okay, everyone. So I think that is where we'll take a stop for today. And let's continue from here tomorrow. So we can discuss any queries, doubts, or that you may have in tomorrow's session. Yes, 10 to 12. Okay, everyone. See you tomorrow. Thank you so much. Have a great day ahead. Bye.